Hey everyone, I'm Dan Sagan from Hydro Ottawa, and I'll be hosting the ThinkEnergy podcast. Are you looking to better understand the fast-changing world of energy? Well, the ThinkEnergy podcast isn't your ordinary energy show. Every 2 weeks, we take you on a tour and discuss, through a communications lens, some of the coolest trends, emerging technologies, and latest innovations. So stay tuned as we explore some traditional and some quirky facets of this industry. This is the ThinkEnergy podcast. Hey everyone, welcome to episode 8 of the ThinkEnergy podcast. A lot of people think LEDs are a relatively new invention, but truth is, the first LED was invented in 1962 by a 33-year-old scientist at General Electric. Did you know LED stands for light-emitting diodes? I'm sure you didn't know that. And they are becoming more and more prevalent as advancements in LED technology continues. LEDs actually got their start as indicator lights for circuit boards and small electrical equipment. That's pretty cool. Converting to LED lighting has several advantages compared to conventional bulbs: longer lifespan, reduced maintenance requirements, and lower electricity consumption. So here's today's big question. How can we leverage LED technology to increase sustainability and efficiency at a grander scale? To expand on this, my guest is RobKent, an engineer from Envari Energy Solutions, who will share how municipalities and their constituents can benefit from LEDs. Rob, thank you for joining us today. Could you tell our listeners what attracted you to the energy sector and what's your role at Envari?
Sure, yeah, thanks for having me. I guess as an engineer, I've always thought of the energy sector being pretty synonymous with engineering. Lots of ties to the engineering field. As I was learning about my options in the field, sustainability drew my attention quite a bit. It allows me to apply technical aptitude while helping save the planet. You know,
that's a big, bodacious goal.
Yeah. Well, who doesn't want to be on the good guys' side of the whole sustainability environment issue, right? As for Envari, we started as Energy Ottawa, actually, and have since undergone a rebrand. The name is part of that. We consider ourselves a one-stop shop for all kinds of energy solution services. We're energy specialists and professionals that help our clients save money and reducing the impact on the planet. We help our clients transform existing assets into something more sustainable through measures, actual recommendations and reports, but also implementing them and carrying them through to implementation and execution. Yeah.
So I'll start with a nice little question here. In 1885, Ottawa was the first city in the world to light all of its streets with electricity. We've been lighting our streets the same way for close to 135 years with practically the same technology. Why should municipalities consider switching now to LEDs?
Yeah, to talk to your first point, first of all, that fact has always astounded me. That's impressive as an Ottawatonian. Ottawan, whatever that's called. To build on your point, there have been some advancements, even major ones, in the technology over the years, but inherently the technology is all similar, has been all similar. There have been several iterations of incandescent lamps, followed by gas-charged electric lamps, and then there have been some major shifts in the gases and the gas mixtures used in them, but as you say, they've been essentially the same thing. Nothing nearly as impactful as the technology shift to LEDs. It's a whole different technology, right?
So why should municipalities consider switching to LED?
I think most of the basic benefits many people know, major energy reduction, improved life, reduction in maintenance costs, more sustainable for the environment, those sorts of things. But as we've done more installations, we've collected more and more data. We've become very data-driven in our approach, and the data itself is showing kind of repeatedly that we're able to achieve in excess of 60% in energy savings for street lighting jobs. Maintenance costs are reduced by about 50%.
So that's great news for municipalities.
Absolutely.
Or any individual property manager, as an example.
That's right.
Those. Yeah,
exactly. It's kind of a slam dunk from a payback point of view, return on investment. We're at a point now where the costs have gone down, the efficiencies have gone up. When LEDs first came out, there were anyone who was actually doing a big street lighting project or outdoor or indoor, whatever, it was a little more risky. Now the technology is plateaued a bit. It's still being tweaked. There's still some efficiency improvements, but for the most part, I think anyone who's waiting for something to improve or costs to go down, I think that they are wrong to do so. The opportunity cost is way too high to be waiting at this point, because there isn't much more shifts, I don't think, coming down the pipe. One of the other major considerations, I think, that a municipality should make is the increase in their ability to control. This is a new thing we haven't had the option for in the past. Now it's the standard. Before, it was practically impossible. Depending on what the client's willing to invest, we can get into dimming functionality, color changing, metering functionality, the ability to build out a smart city platform. Networked controls. With networked controls, the client can see what the assets are doing. They can fine-tune the light output so they can really tweak their savings and get exactly what you need for light on the roadway. Historically, streets were a little more over-designed, a little less specific in their design, because what they had to choose from with the HPS lighting, the old high-pressure sodium, you either put in a 70-watt bulb, 100, 150, 200, 250, or 450. Or 400, sorry. And that was kind of it. Now there are essentially an infinite number of wattage inputs and light outputs through dimming controls. So that's one of the biggest benefit. That's one of the benefits from the actual LED light fixture over the high pressure sodium fixture. Exactly.
Is that component that you can actually go 1 watt at a time if you would.
If you're willing to invest in dimming controllability, there are all kinds of other benefits that we'll get into as well. Yeah, absolutely.
What's involved in tackling a 58,000 streetlight conversion project? Like, I know you guys took care of the city of Ottawa, the partnership. You're in it right now, but converting to 58,000 lights, that's a lot. Can you expand what's involved in doing such a big project like that?
It's been a taking on. I couldn't have imagined going into it what it would have entailed, but being the lead engineer on the project, I've gotten to see every detail from the design to the project management to the implementation, all the challenges that come along the way. As you said, there's a total of 58,000 that are intended to be converted. We're well along the way. It's a 4-year project intended to be done June 2020. That started in June 2016. So
you're on track?
We're on track. We're on budget, which sometimes is hard to say for big projects that span over many years.
What are some of the benefits of LED light fixtures over the high pressure sodium fixtures?
Yeah, well, we've already talked, I guess, about some of the numbers, the economics and the sustainability, the environmental impacts. But just as the average person walking down the street visually, there are obviously some big difference. I'd say the two major differences would be the color rendering ability of an LED and the color temperature options. I'll get into those.
Because you're going to bleed into my next question here, because that will be a good one. Because I do want to talk to you about communities looking different from one street to another. You could see, so maybe you can expand on that.
Exactly, and especially different from the way they used to look as well. Yeah. Color rendering is the light source's ability to have an object appear the way it truly should appear, the way that it would appear under the sun.
So we're talking about kelvins here. We're actually talking about...
No, that's color temperature.
Color temperature.
So this is color rendering. Color temperature is the appearance of the color of the light itself. Color rendering is the light's ability to represent the color of an object that it's illuminating. So they're not they are related, but they're not proportional.
Okay.
There's no mathematical equation that associates the two, although they do have a lot in common. So previously, the HPS, the high pressure sodium lights, they had a color temperature of somewhere in the 2000 low 2000 kelvins.
So that's a very warm light. That's
very
that's a yellowish, not bluish.
That's right.
Yeah.
And it's a monochromatic source. So the only color rendering that it was able to achieve was for objects that happen to be a similar color as that. Everything looks orange at night, right? Some people like it. It's very subjective. Some people don't. But now with LEDs, they have a much higher color rendering index. We're talking like we've gone from low 20% color rendering to anywhere from 70 to 90% color rendering. And so, you know, for the first time now at night, the grass is green. You have a blue car that looks blue at night now. Everything used to look orange, but it also pertains to safety. They're perceived safety in some situations, but there's something real about the fact that you can now see the guy walking down the street with a purple shirt that stands out against the green grass. Before, everything just looked orange. And so that's one thing. The color temperature is another thing. So the temperature is always a confusing point for some people because how is color related to temperature? Really, it boils down to, at some point, someone made a standard where they heated a piece of iron or some black body. They literally heated it up to a certain Kelvin temperature, and at that point, what color was it? And now, so we've given names to colors that are associated with temperatures. So that's how that works. But generally, the higher you heated this object up, 5,000 Kelvin, you get a much cooler color temperature. Lower was in the 2,700 Kelvin range. We consider that kind of a warm color temperature.
Let me ask you this. I think you've been touching on this. So why do communities look different with LED streetlights? Why do some LED streetlights appear brighter? But as an example, my area, my street looks darker. Are there different requirements, or how do you control and why do you control these different environments?
Yeah.
I'll throw in a park as an example. A parking lot, and a residential street.
Yeah, absolutely. And a residential street compared to an arterial commercial street too. Yeah. There's an absolute difference. It's not just a perception. There are, I think, two factors in that, at least in the city of Ottawa. We've adopted at the city's, per the city's policy and their request, we've gone with two different color temperatures. Local roads, the residential streets like where you live, low pedestrian areas, we have a lower color temperature. 3,000 Kelvin we've put on the residential streets. And on the more commercial, high pedestrian, higher traffic areas, a more neutral white 4,000 Kelvin. And so there's this mix. When you drive off of your residential road onto a commercial road, there's
one looks brighter and bluer?
Yeah, there's more blue wavelength in the higher color temperatures, typically, although that's not as simple as that. You can have different wavelengths represented in different color temperatures. But there's also a perceived brightness increase when you go cooler in temperature. When you go from your residential 3,000 K to a 4,000 K on a commercial street, the whiter the color, we've found that people tend to perceive it as brighter, even though on the road it might be the same. Now, the other point, which is a very, very big factor in the answer to your question, is that there are road classifications involved. The city has a policy for lighting their roadways to certain classifications. So the local road where you live has a much, much lower classification due to the lower traffic of pedestrians and vehicles. the safety associated with higher commercial arterial roads, there's a lot more at play. We need to light those roads to a much higher standard. So when you drive off of your road from your residence onto an arterial, you're getting the change in color temperature, maybe a perceived brightness shift from that, but also there's real difference in light level. Yeah.
I can see there's a lot of science behind this. I didn't think it was that complicated. This is very impressive. Leading to the next question here. So, as a business, if I was to ask you this questions through the business lens, is this a competitive marketplace? What makes Envari unique within that space? There's got to be other suppliers. So, what makes you guys different?
Yeah. I would say it's an extremely competitive marketplace. We operate in, typically many companies are attracted to big projects. A street lighting project is a great example. It's a big project. Whether they're experts in the field or not, this is something that they want and compete in because they have the pockets to be able to, and they outsource to get that foot in the door, because of the longevity of the project, the dollar value. They want those projects. Envari has an advantage in that marketplace that makes us stand out, in that we have a lot of experience in it. We've been in the lighting industry for a very long time, between the
lighting, energy management,
lighting. Yeah, exactly. And our people are the difference, I would say, over a lot of other companies. We've got over 100 years experience in this marketplace, well before LEDs came along. A lot of companies kind of pop up as this low hanging fruit. Everyone wants to shift their technology over to the LEDs, and we've been there long before. We know what's at play a little bit more than others. We're involved in governing bodies within the industry, such as the IESNA, that's the Illuminating Engineering Society of North America. We're passionate about the industry. We always have been. We always will be. I think we have a major benefit to our clients, which is, again, that we're a one-stop shop. The client, typically, with the way it works with a lot of other companies, they have to go to separate companies for the different processes of a project. You go to a consulting engineer for the design and the drawings, and then you go to a separate contractor to provide pricing to do the work. You go to different vendors to procure the
you're
product.
A one-stop shop. Like you can provide that turnkey solution.
The project management right through to implementation, absolutely. We're one point of contact too. So whether it's positive or negative, the client knows who's responsible. Yeah. And it's us. We take on all the risk and responsibility.
From installation to maintenance, everything.
That's right.
Okay.
Exactly. Cool. Typically in the industry, as aspects of a project change hands and firms through different companies along the way, the original design intent often changes. Sometimes it's to squeeze an extra buck along the way. Yeah. Because we're involved start to finish, we're able to uphold that quality. Nothing wavers from the initial design intent unless it's directed by the client. And so we have control over that level of quality. The initial intent is maintained.
Cool. Okay, my last question here, but this is a bit loaded, a bit complicated. Maybe it's not for you, but it is for me. Can you help me understand how LEDs fit into a smart city model? Maybe unpack for our listeners and for me, what is a smart city? We're hearing it everywhere.
It is a bit of a buzzword. Yeah. I think the term is a little overused in the market right now, and I think we have marketing groups to thank for that. But smart city means a connected community. What it really means is putting devices in the field that help the community function better. We have street lighting infrastructure is a great platform to build out a communications network across the city. that we have some extra bandwidth that we can add additional functions to that base system. And if additional bandwidth is required, the infrastructure's there. We just need to add that bandwidth, and that's possible with additional.
You mentioned devices. So streetlights are one device. What other type of devices are you referring to? Right.
So parking detection, anything that you can think of that would make a community operate better. Climate detection, sound, noise, gunshot detection is a hot topic. Okay. If you can triangulate where a gunshot came from.
So what are you saying? So if there's that sound, the lights pop a bright white within that area?
That could be, or it's a sensor that communicates directly, is a line of communication to the police force to say, here's the location of that gunshot. Okay. That's an example of that. There's all kinds of traffic counting, pedestrian counting, ways to help communities go in and out of a very busy place more efficiently. I think is how I would best unpack that. Streetlights are an easy asset to look at for building the smart city platform, because they're everywhere. They're located periodically. They're powered across the city in high traffic areas. It's just a good opportunity to power external devices in frequent locations.
Rob, this was very informative. You've truly given me a new view on streetlights. If people wanted to connect with you, what's the best way? How could they reach out?
Well, I'll say go check out envari.com, and we have a contact landing page. You can leave your info. You can make a request. Any information you want, we monitor it, and we'll get back to you.
Are you on LinkedIn?
I am.
There you go. So we RobKent on LinkedIn?
Actually, I'm not. Now that you mention it, I used to be.
Okay, good.
Let's change that answer.
Okay, there you go. That's pretty funny. Okay, good. That's it. Thank you very much for joining us today.
You're very welcome. Thanks for having me.
Cool. Hey, folks. Thank you for joining us today. I truly hope you enjoyed this episode of ThinkEnergy. For past episodes, make sure you visit our website, hydroottawa.com/podcast. Lastly, if you found value in this podcast, we'd appreciate a rating on iTunes, or maybe even tell a friend or a colleague. Anyway, this podcast is a wrap. Peace, everyone.